In this video, we're going to look at the plagioclase solid solution series. And this corresponds to the right side, the continuous side of Bowen's reaction series. First, let's look at the composition axis. And what I'd like you to have in front of you right now is the paper that has the problems that you just worked out for the binary eutectic. You did the first two. The third one is a solid solution problem, and I'd like you to be looking at that as I speak. Okay, on the right-hand side, where I've got 100% AN for anorthite, you can see on your diagram, which has a little bit more information, that anorthite is made up of calcium plus aluminum plus silica plus oxygen. In other words, it's a calcium aluminum silicate. In a certain spot in this structure, right now there are 100% atoms of calcium. Go to the other side. The other side is albite. It's a sodium aluminum silicate. In that spot where anorthite had calcium, albite has sodium. 100%. You can vary these two constituents in any proportion whatsoever. Notice on yours where mine says percent AN, yours says weight percent of calcium. That's more accurate, and that's what you should you should go by. All right, now geologists decided that this range should be broken up into 6 minerals. It was a very arbitrary decision. They could have made it 3 minerals, they could have made it 10 minerals. They made it 6 minerals. They said that if the calcium content varies between 0 and 10, they would call the mineral albite. If the calcium content varied between 10 and 30, they would call it plagioclase. 30 to 50, and they would call it andesine. 50 to 70, and they would call it labradorite. And 70 to 90 bitonite, and 90 to 100 anorthite. And those numbers refer to the percent of calcium. All right, let's look at our sample here. Our sample has a composition that's marked by a dashed line. It just happens to be at the 50% calcium mark. Now this looks very different from a binary eutectic. In this type of phase diagram, the top portion is liquid, the bottom portion is solid. The top line is liquidus, the bottom line is solidus. So we're going to start with our melt. We're going to cool it to point A. Now, if we want the temperature of point A, we take a straight edge and we line it up, make a mark over here, and then figure out as precisely as you can where between 1400 and 1500 the temperature falls. And that is a separate video named Determining Temperature. I'll move this out of the way. All right. The next thing we want to know is what is the composition of the first crystals to form. And to do that, we read across to B. From B, we have to read down to the composition line. So I'm going to get my ruler here. This is a really clever little guy. This is called screen ruler. Looks like 90% to me. So the first crystals that form will be 90% calcium, and 90% calcium we would call anorthite. Now, let's cool the melt a little bit more. Let's cool it down to C. Once again, we could read directly over to figure out the temperature. Let's do that. It's going to be below 1400, so you're going to have to do some measuring. To find the composition of the crystals now, we need to go to D. Okay, I just want to make sure my ruler was straight. I would make a mark here, right here, and I would determine what percentage of calcium that was. Now, here's where it gets tricky, guys. Remember the 90% crystals? They're gone. They're gone. They've reacted with the melt, and they are at this new percentage, which is very hard for me to tell with this ruler not being see-through. It looks like it's more than 85%, maybe 86, 87%. All of the crystals now are 87%. Okay, look at the tie line. I can do the same thing with this that I did with the tie line in the binary eutectic. I can figure out the percent of the system that's a solid and the percent of the system that's a liquid. Okay, now this is the liquidus, right? So if I take segment X and divide it by X plus Y, I should be getting the percent. Did you say solid? I hope so. If you took Y and divided it by X plus Y, because you're intersecting the solidus, you should get liquid, right? All right, now let's continue cooling this down to E. At E, the crystals that form will have the same composition as the melt that we started out with. All of the crystals will have this composition. All of the crystals that form to start with will react with the melt to come to this new composition. That is what makes the solid solution different from the binary eutectic.